Exercise 11.3, right triangles. Today we are going to focus only on right triangles. So everything we're going to talk about is only true for triangles if they contain a right angle. Our basic trigonometric identities, the acronym that helps us remember those identities is SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So here are our three basic trig functions: the sine function, cosine function, and tangent function. On your calculators, abbreviated SIN for sine, COS for cosine, and TAN for tangent. When you talk about them in terms of their names, not their abbreviations. So talk sine, cosine, tangent. In this triangle, we're looking at everything in relationship to this angle theta right here. So the first thing you should do is always identify where the hypotenuse is. In this triangle, remember the hypotenuse always has to be across from the right angle. So here's the hypotenuse. Now, depending on what angle you are using is going to depend on which side is considered opposite and which is adjacent. Since we're talking about this angle theta right here, the side opposite theta is right here. So this is the opposite side, which leaves then this has to be the adjacent side. So now if sine is opposite over hypotenuse, sine of theta is going to be A over C. Cosine is adjacent over hypotenuse, so cosine is going to be B over C. And tangent is opposite over adjacent, so tangent is going to be A over B. First example here, find the sine, cosine, and tangent of angle A. Sine of angle A. Sine is opposite. What side is opposite angle A is 3. Hypotenuse is 5, so opposite over hypotenuse is 3/5. Cosine adjacent over hypotenuse. Which side is adjacent? Well, 4 is adjacent. Hypotenuse is still 5, so the cosine is going to be 4/5. And finally, tangent is opposite over adjacent, so 3 over 4. Second example, what is the length of side AC given that the sine of x is 3/4? Well, some things we need to know here. First of all, we're dealing with a right triangle. That's the only way we can use our right triangle trigonometry of SOHCAHTOA. Second of all, sine of x is 3/4, and we know sine is equal to opposite over hypotenuse. So if we set up a ratio here, 3/4 equals, that ratio has to equal our ratio of the side opposite to the hypotenuse here in the triangle. So let's call this side opposite here A, since it's across from angle A. Opposite is A, hypotenuse is 16, so if I fill out my proportion and I go opposite over hypotenuse, we should be able to now solve this for A. If I multiply by 16 to get A by itself, in your calculator, take 16 times 3/4, and we find that A is equal to 12. So I know this bottom side here is 12 units long. Now what we're looking for is the length of AC here, which I am just going to call B since it's opposite angle B. Well, if I have a right triangle and I know two sides, we can always find the third side by using Pythagorean theorem. Let's do that. Leg squared plus leg squared equals hypotenuse squared. Use your calculator. B squared plus 144 equals 256. Subtract the 144 over. B squared equals 112. Plug that into your calculator, take the square root, and you get approximately 10.58. Two special right triangles that you're going to be working a lot with in the next few homework assignments. 45, 45, 90 triangle. 45, 45, 90 triangle. The sides will always be in these ratios, 1 to 1 to root 2. So you need to remember 45, 45, 90 is 1 to 1 to root 2. Some things should make sense to you here. First of all, remember what we talked about before about across from equal angles has to be equal sides. So that means these sides always have to be in a ratio of 1 to 1. Hypotenuse is always going to be root 2 in a 45, 45, 90 triangle. So using those ratios for this first example. If you see a 45, 45, 90 triangle, write down exactly what we had on the previous slide. 45, 45, 90 is 1 to 1 to root 2. Now, simply take each one of those and you are going to make a ratio now of what you are given in your new triangle. So I'm going to turn each of these into ratios by simply filling in what's across from each angle. What's across from the 45-degree angles? Well, A is and 5 is. What's across from the 90-degree angle? C. And now you can take any two of these ratios that you want and simply set them equal to one another and solve for whatever is missing. So the first thing I'm going to do is I'm going to take these first two ratios, 1 over A equals 1 over 5, cross multiply, A is 5. There's side A, which we also should know right away because we know that these two sides have to be equal because they're both across from a 45-degree angle. Take another set of ratios. I'm going to take this one and this one. 1 over 5 equals root 2 over C. Cross multiply. C equals 5 times root 2. And there's our other missing side. Second triangle here. I'm going to start the same way. 45, 45, 90. It's 1 to 1 to root 2. Fill in the missing sides. Across from these two sides are A and B. Across from the 90-degree angle is 6. What do we know again right away about A and B? Well, we should know that A and B have to be equal to one another, which means if I find one of them, I know the other one has to be the same, so we should not have to do this twice. Let's find A. If I use A, I'm going to use that ratio along with the ratio that I know. So we have 1 over A equals root 2 over 6. Cross multiply. 6 equals A root 2. So A is going to equal 6 divided by root 2. From here, you will not see an answer written in that form. Okay, so what you are going to need to do, if you can get to this far, you still should not ever miss the problem because remember, you can always go and plug that into your calculator, plug the answers into your calculator, get the decimal approximations and see what matches up. What they are going to do is called rationalizing the denominator. When you rationalize the denominator, that happens when you have a radical down in the bottom. You're simply going to multiply by that individual radical over itself. So now I get 6 root 2 over root 2 times root 2 is root 4. Square root of 4 is just 2. Finally, simplify. 6 divided by 2 is 3. So we know that side A is 3 root 2. If A is 3 root 2, we know B also has to be 3 root 2. So 45, 45, 90, 1 to 1 to root 2. 30, 60, 90 triangles has a very similar relationship. In a 30, 60, 90 triangle, the sides will always be in a ratio of 1 to root 3 to 2. So once again, this is what you need to have memorized. If you know that, it's going to be a matter of, again, filling in what's across from the 30-degree angle, what's across from the 60-degree angle, what's across from the 90-degree angle, and solve your proportions. So here we have 30, 60, 90 triangle. Ratio of sides is 1 to root 3 to 2. Fill in what we're given here in this triangle. What's across from the 30-degree angle? A. What's across from the 60-degree angle? B. What's across from the 90-degree angle? 6. Now from here, just to make things a little bit simpler when I solve these proportions, if you ever have a ratio like this of 2, 6, that can be simplified. Remember, ratios we should always simplify. So I'm just going to note that that's the same as 1 over 3. So now pick two of the ratios. I'm going to pick this one and the one that we know always. 1 over A equals 1 over 3. Cross multiply. A is 3. There's our first missing side. I'm going to pick this ratio to find B along with the one that we know. Root 3 over B equals 1 over 3. Cross multiply. B is 3 root 3. There's our two missing sides. Last one, 30, 60, 90 triangle. 30, 60, 90 is always 1 to root 3 to 2. Across from 30 is 2. Across from 60 is A. Across from 90 is B. If I solve for A first, I'm going to choose that along with the one ratio that I know. So I have 1/2 equals root 3 over A. Cross multiply. A is 2 root 3. I'm going to now find B. So I'm going to pick that ratio involving B along with the one that I know. 1/2 equals 2 over B. Cross multiply. B is 4.